Hi, grade 8. This is a math assignment dealing with lesson 5-4, where we are talking about how to divide rational numbers. Uh, First step, let's see if we can remember the rule for division of fractions. To divide fractions, you multiply by the reciprocal or the multiplicative inverse of that second number. To divide, you multiply by the reciprocal or the multiplicative inverse of the second number. Before we get started, what in the world is a reciprocal or a multiplicative inverse? Well, it's pretty easy in the case of certain fractions. All you do is flip the numbers. The reciprocal of 1/2 is 2 over 1, right? If I wrote 3/4, the reciprocal of that would be 4/3. What makes it a reciprocal or a multiplicative inverse? Well, the technical explanation is that they need to be two numbers that when you multiply them together, you get the number 1. And that's part of that definition of multiplicative inverses. What if you had a whole number, like say the number 12? What would be its reciprocal of multiplicative inverse? Well, first turn it into a fraction, then flip it. There's the multiplicative inverse or the reciprocal of 12. Okay, what if I had a mixed number? Change the mixed number to a fraction. 2 times 3 plus 2 is 8, 8/3, and then flip the numbers. Oops, not an equal sign. That is the reciprocal or the multiplicative inverse of that. Okay, let's start using this to solve some math problems. How would I solve this first one right here? To divide, I multiply by the reciprocal of the second number, and I get 10/2, which is the number 5. Right? Let's do this bottom one. To divide, I multiply by the reciprocal of the second number. Ooh, you know what? I'm going to do some simplifying. Divide by 9, divide by 9, divide by 2, divide by 2, makes it a whole lot easier. I get 36 over 11, and 36 over 11 is 3 3/11 once I do the simplifying or the changing back into the mixed number of that particular item. How about this top one up here? That would be negative 15/16 times the reciprocal. Oh, is there a simplifying I can do? Yep, divide by 4, divide by 4. That gives me negative 45 over 28. Remember, a negative divided by a positive is always a negative. Then I can change this back to, I can do this long division, and I get negative 1 and 17/28 as my final answer there if I do use long division. Here I'm going to have to change it to a fraction first, and then I'm going to have to multiply by the reciprocal. Ooh, I can divide by 5 and divide by 5. I get 23/2, which is 11 1/2 if I do the long division to change it back into a mixed number. How about this one? Negative times the reciprocal. A negative divided by a negative or multiplied by a negative, it's going to be a positive answer. I can divide by 3, and I get 9 over 8, which is 1 1/8 when I do the long division. Oh, here's an interesting one. 0 divided by a number. The answer is 0. Don't even have to work it out. But if I did, it would be 0 over 0 times 8 over 7, which equals 0 over 0, which is the number 0. How about this one down here? Woo! What is that? That's 54 55/3 times, what is this? This is 24 25/6. So I'd have to flip it to 6/25. I've got a positive divided by a negative. Hey, I can divide by 5. And I get negative 66 over 15. I could have also divided by 3 and divided by 3. That would have made it negative 22 over 5, which is negative 4 2/5 when I do the long division on that. Whoops, it's off the screen a little bit. Okay, how about this last one here? This is 12 and 5 makes 7, negative 17/6 times 51 over 3, I think. Yeah, times 51 over 3. Any simplifying I can do? Wow, no there isn't. Oh, for sure, yeah, actually there is. Divide by 3, divide by 3. And I get 6 on the bottom and negative something really big on the top. I don't know what 17 times 17 is. Looks like negative 289. Yep. So, let's see. 6 goes into what? I don't know, 289. How many times? Is that on the screen? Looks like it is, slightly. Be 4 times. And 7 times. Whoop, how about 8 times? So I get negative 48 and 1/6 is my answer for that one. Negative 48 and 1/6. Okay, so that's one type of problem. But there's also going to be problems with variables in it. Variables. Let's take a look at this one right here. It's still multiplied by the reciprocal of the second number as our method. Multiply by the reciprocal. Hey, I can cross simplify. Divide by 3. Divide by 3. And in this case, I get 6x over 1, which is just plain 6x. Next one over. Let's multiply by the reciprocal of that second number. We're flipping the numbers around. And I got 4k and 5 on the top here. Wow, this is going to be an interesting problem. I get 6k to the second power over 125. Did you catch that? 6k to the second power over 125. And that would be wrong. Think about it. 4 times 2 is not 6. 4 times 2 is 8. K times k is k to the second. This is really 4 times k times 2 times k. So that's why it's k squared here. There's no simplifying we can do on that problem, so we're kind of stuck. Okay, how about this one? 2c over b times the reciprocal. There's some. I can simplify. Divide by b. Divide by b. How about divide these by 2? Divide by 2. Divide by 2. What are we left with? We're left with 1c. Don't forget that c. 1 times c times 1 over 2 times a. I get 1c over 2 times a. Now, do we have to write the 1 in front of that c? No, we could also write it as c over 2a. Either one of those would be acceptable. Okay, let's move on to this problem. 3 times s times t over r times r over 4 times t. Hey, I can simplify the r's to 1s. What else? I can divide by t and divide by t to make those into 1s. What are we left with? 3 times s times 1 times 1. 1 times 4 times 1. And I'm left with 3 times s over 4. How about this next one? Negative 2x over y times the reciprocal of the second number. I can divide by y and divide by y to turn those into 1s. And what does that give me? Oh, wait. I can divide by 2 and divide by 2. That gives me -1. So what are we left with? On the bottom, we're left with a 2. On the top, we're left with -1 times x times 1. That'd be -1x. Now you could write it like that, or you could write it like this as well. Either one of those is acceptable. Let's come back way over here. M to the second power over 2 times n times p times the reciprocal. Any simplifying we can do? Yeah. How about p divided by p? P divided by p is 1. P divided by p is 1. How about the 2 and the 4? We could divide those by 2. And 4 divided by 2 is 2. 2 divided by 2 is 1. What are we left with? M to the second times 2 times 1. Isn't that 2m to the second? And then on the bottom, 1 times n times 1 times n. That's n to the second power. That's n times n, which is n to the second. Okay, how about a to the second over b to the second times the reciprocal of the second number? Ooh, this is kind of cool. I can divide by b to the second, divide by b to the second, and I get 1s in both spots. And this one finishes pretty fast. A squared over c squared. We're done. A squared times 1 is a squared. 1 times c squared is c squared. How about this one? Let's start by first putting it over 1. And then let's rewrite it, multiplying by the reciprocal of that second number. Right? Isn't y squared really y times y? And so can't I divide by y and divide by y? And that gives me 1 over x times y. X times 1 times y is x times y. How about this one? Multiply by the reciprocal of that second number. B over a becomes a over b. And hey, I can divide by b and divide by b. And I'm left with a to the second power over 8. A to the second power over 8. And finally, this last one. To divide, we multiply by the reciprocal of the second number. Hey, I can cancel out the a's. I'm left with 8 over 4, which is the number 2. 8th graders, hope this helps you. Adios.